Hi guys. So I've been thinking about doing an incremental reading stream or video for a long time, just where I basically open SM, go through my queue, and basically people can just watch sort of what someone who's been using SM for a while actually does day to day. But I've also been kind of reluctant to make that kind of video just because it's very difficult to make this kind of content interesting and engaging for people who are watching. And I think a large sort of component of that is due to the fact that incremental reading, doing spaced repetition items, it's all kind of an internal process for the learner. So it's not very easy for someone to sort of think aloud while they're doing incremental reading and make it interesting for the people watching. But what I thought I'd do is try and take inspiration from those wonderful Call of Duty commentaries that I grew up on as a kid. And I'm going to try and commentate the process where I can, and where there are periods where I'm just not talking at all and I'm just focused on reading or taking extracts or creating items or whatever, I'll go back during the editing process and add some commentary and try and give you some insight into what was going on in my mind. So yeah, today I'll just be focusing on topics. I think I set the sorting queue purely to topics. So I'm just gonna be doing reading because I find watching people do that items pretty boring, and I don't want you guys to endure that. So that's about it. So without further ado, I guess I'll just get into it. All right. So this was the first session back doing incremental reading after perhaps a month or so, where I did basically hardly any incremental reading or incremental writing or anything else with SuperMemo. I basically just focused on programming and tried to get my items finished, which I didn't always do. So it seems like the last time I'd used SM, or perhaps in the period when I was using SM quite heavily, a month or so ago, I had made a bunch of extracts about the explore exploit problem. So they are going to feature pretty heavily during this session today. And I guess I should probably briefly explain what exactly is the explore exploit problem. It basically refers to problems where you have to balance resources, for example time, between exploring new options, trying to find a new best option, and exploiting the best option you've already found to gain some sort of value or benefit. And basically the canonical example of this is the multi-armed bandit problem, which basically refers to a casino which contains a bunch of slot machines, and you have to allocate your money between slot machines to try and sample each slot machine and find out which one has the best win-loss ratio, basically. And you need to find a balance between trying new slot machines and just putting your money into the slot machine that has given you the greatest expected value so far. So obviously this has many applications in the real world, like in clinical trials, also learning, of course. You've got to balance your time between searching for new exciting areas that you can learn about and learning about those areas that you already know to have useful information in them. Interestingly, it's also a very difficult problem to solve, the explore exploit problem. I read on Wikipedia that Allied scientists, they airdropped this problem over Germany during World War II to get German scientists to waste their time trying to solve it. So that's pretty interesting. I like to make these sorts of items that ask about something fundamental and simple, and my sort of the logic behind that, even though I think right now that I will definitely remember these items, and so perhaps you'd say, well, there's no point in making the item. The logic behind making the item anyway is that if you get an item correct in SM, every time you are shown it, you will only be shown it 6 times, perhaps over a lifetime, which is such a trivial investment in terms of time to remember such an important and fundamental fact that I always think that it's worth to sort of solidify the fundamentals of a subject. And I think that probably differs with the approaches of many other people, and part of it comes down to perhaps what algorithm you're using. For example, if you're using an algorithm that does give you a higher rep load, even if you get every repetition right over a lifetime, then you're going to be more cautious in terms of which items you make. You might only be willing to make those items that are extremely important to you and that you know you can get right. But to me, it's so important to remember the fundamentals, and the cost seems so low that I'll always take something nice like this. Oh yeah, one other thing I'll say is that whenever you see these magical arrows, this is just my syntax sort of indicating that this is a note that I wrote myself rather than being part of whatever I extracted this paragraph from. It serves literally no purpose other than to simply indicate that fact. But yeah. I really like this framing of the explore exploit trade-off as a sort of conflict or tension competing for your attention. The attention economy is always something that I'm talking about with Nice and Strategy, for example, on the podcast. So yeah, I really like this framing from Peter Whittle. But I don't have really anything more to add. So what I'll do is I'll increase the priority. I want to see this again. I want it to be shown to me early in my queue the next time I see it. So I'll update the priority and just move on. Oh yeah, and the importance of the interval in the importance of time, how long you decide to spend, for example, in the casino. That's also important. But yeah, I don't really have anything to add at this time, so I'm just going to move on to the next stuff in my queue. See, this is really, it's really important information, and I love that it's given an instance of why traditional clinical trials, they can be unethical and inferior to other sorts of experiments, for example, using Thompson sampling instead. But I just can't think of a good way to formulate this right now. Please leave a comment if you do find a good way to formulate this, because I think it would make a really good item. I just can't think of a good way to frame it. I actually posted this short paragraph up on Twitter, and I'd love to draw on the collective intelligence and expertise of the audience to help me formulate this item. So if you have any good ideas, you can follow me at experlearning. That's like experiment without the ment, and learning. Yeah, I'd love to hear your ideas. I was kind of thinking about what instances of the explore exploit problem can I think about in real life, and one of them that I really like is how does the meta how does the meta change in online video games? So for example, I've never played League of Legends, but I know this is surely one of the things that is discussed amongst League of Legends nerds. What's the best character to pick? What's the best hero to choose? How should you arrange each character on the map in order to
give yourself the best sort of strategic advantage, increase your chance of winning. So when you're in a League of Legends team, should you invest resources into sort of just choosing the dominant meta that everyone's sort of converged on and that is sort of publicly known, or should you invest time into finding alternative strategies that other people won't expect that could then become the new dominant meta, right? And so I think a classic example of that is the Frosbury flop. You know what? I've got the internet. Why don't I just look? Edge. Right, here we go. Wikipedia to the rescue, as usual. The Frosbury flop, popularized by Dick Fosbury. I've said it wrong. Who brought this new sort of technique, jumping over backwards, to the world's attention, right? So he invested time, rather than just focusing on the dominant meta, the dominant technique in the high jump, he decided to use this, what must initially have looked like a crazy method for getting over the bar, but of course it turned out that this was much more efficient than the alternative traditional approach. So that's one example of like this problem, I guess. The tension that exists between acting on one's best knowledge, using the dominant meta, or just gathering more, trying to find a new one. And also, where does the drive to challenge the dominant meta come from? Like, why did Dick Fosbury search for this? Like, my hypothesis was always that the drive to find the new dominant meta would come from the underdog, someone who's not performing well at the current time. Like, if you're already if you're the incumbent, it's more likely that the challenger is going to be the one exploring, trying to find information that can defeat the incumbent strategy, right? So let's see whether that's the case. Let's look at the history of Dick Fosbury. Right, here we go. Fosbury, he started experimenting at 16. He had difficulty competing using the dominant high jumping techniques of the period. So he failed to complete jumps of 5 feet, right? So he couldn't even get into these track meets, right? This dominant technique, he's the underdog. The straddle method is the dominant technique. Yes, this is excellent. All right. I don't know why I opened it in Edge. I'm going to have to open it in Incremental, in Internet Explorer just to import it. But let's see. Oh, what a mess. Ask me later. Go away. All right, so I'm just going to import this as a child of the current element. I always do that. Import as a child of the current element. I know it's not optimal. Like sometimes it's good to import into a concept new node or whatever. I don't know. I just sort of stick with what I started doing as a beginner. So, all right, that's super interesting. I'm glad I checked that out. And I'll get a picture of him. Oops, did I not? Okay. Okay, I'll say this man revolutionized the high jump event with a back first technique now known as the... Yeah, that'll work. That'll work as an item. Okay. Right, lower center of mass. That was the key of his technique. Okay. How interesting. Look, he found it difficult to coordinate all the motions involved in the straddle method and began to experiment, to explore other ways of doing the high jump. Excellent. I'll highlight that. So he invested more time. He invested his resources. I'll just put it in more abstract terms just to make the link explicit between the explore and exploit problem, which is stated in sort of abstract terms. I want to make it explicitly link it to this instance, basically. So I'll formulate it in these sort of awkward abstract terms. Invested his resources. Super cool. So I'll just quickly scan this, see if there's anything else interesting. Interesting. So I wonder if there's a way to link this to the clinical trial thing. Like in a clinical trial, perhaps Fosbury, his coach would have, just forced him to continue using the inferior method in the, to maintain the sort of scientific approach to finding which method is the best. We've got to run this trial, and you're not allowed to use any other method. We need you to test this just in isolation. But instead, his coach allows him to allocate some of his resources to using the flop, for example, in his freshman meet, right? And this sort of approach, here we can't really talk about whether it's ethical or unethical. It's simply, sports ethics don't really come into it in this instance. But obviously, in a clinical trial, if you have people just receiving an inferior drug, for example, then this just becomes critical. It's a life and death thing. So this is super interesting. There doesn't seem to be anything else really that interesting about Mr. Fosbury to me personally, so we'll get rid of the rest of it, just delete. And this branch, I'm in two minds. On the one hand, this is super interesting, and I'm really glad that I checked it out. So I'm actually wondering whether I could write maybe part of an article. Usually what I do if I want to turn something into an article is I'll go to my output folder. So this input is essentially all of my reading, videos, audio, and all of that stuff. My output folder is articles, videos, programming projects, anything that involves releasing creative output into the real world. That's essentially how I define it in an abstract way. So the Fosbury thing and sort of the changing metas in video games and sports, it's sufficiently interesting, I think, to warrant creating an output folder. I actually wrote an article on my website, experimental-learning.com, on the input-output thing. It's called Input and Output in Learning. I don't consider it finished yet. It's kind of still an idea I'm developing, but you can check it out. I'll leave a link in the description as well. Nope, this is completely opaque to me, really. So I'm going to decrease the priority, and also I'll increase the interval to like 60 days. So that'll give me the logic behind doing that, is that if I have 60 days before I next see this element, I'll have had more time to learn the prerequisite knowledge. Now, if I was being really diligent about this, I would actually import the prerequisite knowledge to understand this, or advance the prerequisite knowledge that already exists in my collection into that interval, before the 60-day mark, so that I could learn all of the prerequisite knowledge before this element next comes up. But I can't really be bothered right now. I want to do some more topics, so I'm just going to move on. All right. And at this point, this element has pretty much exhausted all its use, even though it's still got this little note attached. I'm pretty sure I have an item for this already. It's pretty clear in my mind that these Thompson sampling and the rest of the stuff in this paragraph are related, so I'm just going to get rid of it. Okay. Aha. Some Ayn Rand, I think. Objectivism. Interesting. Yes. So, okay. I'm hoping there's going to be someone who watches this that can give me some insight into concept formation. Like, what really drew me to Ayn Rand's work was not The Fountainhead or Atlas Shrugged or any of her literature or any of that. My first introduction to Rand was literally just reading the Introduction to Objectivist Epistemology, right? And in it, she basically her epistemology or her metaphysics, it starts with a really interesting discussion of concept formation. And I don't know whether that exists anywhere else. I mean, I've looked on the internet. I presume it does, since it's surely got to be an important part of philosophy and cognitive science and neuroscience. It just occurred to me that it was super interesting, and I know Ayn Rand isn't taken seriously by, let's say, academic philosophers or just people who are into philosophy in general, but I just couldn't help but get super interested in this whole idea of concept formation, since I think originally my interest in concept formation literally came from concepts in Supermemo and reading Piotr Wozniak's articles, right? Reading Woz's articles. And I don't know, can anyone point me to better sources of information? Can anyone give me criticisms or back up any of the stuff that Ayn Rand says about concept formation? I'd be really interested in reading that. And also it'd be good to have like maybe a source, sort of like a neuroscientific source, like a more low-level understanding of what concepts are. Like, we talk about concepts, how are they arranged in the mind? How do they actually manifest themselves in terms of cell assemblies in the mind, in terms of neurons and synapses and all of that stuff. So if you have any knowledge related to that, do let me know. But anyway, I'll push through, and you can leave any criticism in the comments. I'd be glad to read it. It's all very abstract. I'm going to decrease the priority of this one, although I do think it's pretty useful, especially if I want to read more of Ayn Rand's work. So I'll increase the interval again. In beta cells of the pancreas, don't provoke release of insulin. This is pretty uninteresting, honestly. Decrease the priority to 70. it's interesting in the sense that I didn't realize that action potentials were responsible for doing this. I figured action potentials only, I'd obviously heard of them in the brain, right? Electrical activity propagating down, not dendrites, an axon. It's pretty interesting that also occurs in the pancreas, but it's really not mission critical knowledge, so I'll just bump down the priority to 70 and it'll get buried in my queue for a while. Maybe I'll see it sometime later. Nearly all cell membranes. Voltage difference. Similar to the last one. Not that useful to me right now. 50. I don't know, there's something about this. The idea that a neural network is static and symbolic. I don't know enough about neural networks to disagree in really a coherent way, but it doesn't seem to align with what I've seen of neural networks so far. They seem to be able to recognize like the weights of the neural network. They seem to change in a dynamic way that I would describe as dynamic. So I'm just going to get rid of this one. It's causing some interference, let's just say. And I don't know if it is truly the case that this is true and it's mission critical knowledge, it'll come up somewhere else. So I don't know. I can feel confident just removing this from my collection. Sleep or the brain. Okay. I'm not really interested in the development of a brain, but I am interested in sleep, if there's anything good on sleep. Oh, this is cool. Function. Information from the sense organs is collected into the brain. Oh, yes. See, this sounds exactly like a neural network, right? Biologically inspired neural network. And you can see why, especially when they've written it like this. Function of the brain. Visualized brain. Yeah, this is cool. I'll give this a 5 in terms of priority. I really want to see that again. Perception. Yeah, this is good stuff. Anything about the senses. Motor control as well. Give this 16. Motor control. Yes. Yes, right. Why do we sleep? Why do we sleep? Right? It's common for animals to sleep. It serves some common goal that is consistent across many different species. Where am I? See, this is one of the interesting things about Super Memo and probably my idiosyncratic approach to using it. Stuff just ends up in the most random places, so you can sort of follow the since I always import pretty much as a child, I can follow the tree backwards towards the root, and I can sort of see where the initial things I was learning started and where I actually ended up. So I started learning about deep learning from machine learning, and I ended up at the brain and then into sleep. So it's pretty interesting. But yeah, I almost want to turn this or somehow link it to just a general question of why we sleep. So I'm super interested in that. And Woz has written a lot about it, and I've read a lot of what he's written about sleep, but it really seems like we don't know for sure a whole lot about what the purpose and function of sleep is, and so I'd really like to explore this in more depth. For now, I'll just extract it. Give it a 9. Why not? Learning and memory. Oh, yes. Give me a 5. How brains perform computation. That's pretty interesting. Yeah, that sounds pretty cool. How does a brain compute? I read this really good book by Melanie Mitchell. I think it was called Complexity, A Guided Tour. That was it. Melanie Mitchell. And I recommend it. It was super good. And she talked a little bit about computation in living things. And it was really interesting. For example, one of the items I had from that book was like DNA encodes. DNA is like a programming language, but it also encodes its own interpreter inside of itself. So it encodes like the ribosomes and all of the stuff that interprets the DNA along with it. And I thought that was super interesting. A lot of analogies there to be made between computation, digital computation, and just computation in the abstract general sense of, biological organisms, algorithms, everything. Very interesting. Yes, there we go. I'm sure all of that history is so much, that's so much interesting stuff in it. But this is the real gold. These are the golden nuggets right here. Computational neuroscience. Analogies to be made between electronic computers and the brain. Information theory. What is information? How do we process it? Is the brain an information processing system? Cybernetics. Computational neuroscience. Ah, shit. Ah. I got too excited there and lost my place. Yeah, here we go. Yes, the action potential. See, we're getting more about the action potential. I've definitely heard these names before. Huxley, I think Katz as well. The great topmost sheet of the mass, that where hardly a light had twinkled or moved, becomes now a sparkling field of rhythmic flashing points. It's a really nice way of putting it. I wonder if with this part, the great topmost sheet of the mass, I wonder whether with the mass he's referring to the brain and the great topmost sheet as the neocortex. I've heard like the neocortex just described as this like sheet around the brain. I wonder if that's it. Yeah, here we go. Neural networks. Very cool. Neural algorithms. Even single neurons appear to be complex and capable of performing computations. Awesome. 4. That's top quality stuff. My God. Ah, brain is food. Damn. That's horrible. Wow. My goodness. Right. As for the rest of the article, not so interested. There is good stuff in there. I'll leave it, but I'll deprioritize it. It's not the main stuff that I wanted to get from there. Sleep, senses, and computation, especially computation. So 30, that makes sense. Let's go. I'm wondering whether I should try and explain the idea behind this, since this could really just send me off on a tangent or just devolve into incoherence and just me blubbering on about something I don't really understand. But I was interested in adaptation in just the abstract. So the whole idea was that when you learn, you're just making modifications to some cell assemblies in your brain, right? You're just modifying the strengths of connections between different neurons and so on. And in physical training, you're sort of doing the same thing, right? Let's say you go to the gym and you do some bodybuilding, right? You're going to be doing your bicep curls, breaking down those muscles, and then they get repaired. You're making just progressive changes to the muscle structure over time. And so both of those two instances were so similar to me that I figured that you could treat them as sort of the same thing. Just adaptation in the abstract would just be progressive changes to some structure, organic structure perhaps, over time. No, I suppose not, since you could similarly talk about it in terms of computers, neural networks, artificial intelligence as well. So it was just, can you reframe like some of these things in terms of this abstract theory just based on adaptation amongst can you reframe it in more abstract terms and then look at like what the similarities and differences would be between these different systems? Could we learn anything about that? So I found this guy, John H. Holland, right? I think he's pretty famous for doing genetic algorithms, perhaps. And he's written this book, Adaptation in Natural and Artificial Systems, an Introductory Analysis with Applications to Biology, Control, and Artificial Intelligence. And he's just framed, I think he's basically just answering pretty directly this question, like, how can we just study adaptation in itself, not attached to anything concrete, and then look at what the implications are for those for the applications. And so what I wanted to do was to reframe myself. These were sort of questions he posed almost, I think it was in the introduction. So to what parts of its environment is the organism, system, organization adapting? So it's like, in his abstract theory, there's an organism, system, or organization, and it's adapting. And it's adapting to a part of its environment. So I was going to try and reframe it myself in terms of human semantic learning or physical training, like bodybuilding or whatever, right? And I figured that would give me it would prepare me for the later parts of the book, and it would also just maybe generate some original ideas about adaptation and why it's useful to study it both in abstract as well as concrete terms. So in terms of human semantic learning, the adapting organism. Maybe I should take these terms that occur in these questions and actually just map out what they actually mean within the concrete system. The adapting organism in human semantic learning surely is the human. I suppose if I didn't restrict it to human semantic learning, I mean, can animals learn semantic information? That's a good question. I'll leave it to the viewer to decide. But for now, let's just stick with human semantic learning. Okay, so the adapting organism in this case is the human. To what parts of it, of humans when they learn, what part of the environment are they adapting to? What is the environment? I think the environment is a set of environments. The environment itself is composed of many different environments. Sub-environments, let's say. I almost want to say that a commonality between all of the environments humans adapt to is that there is some resource constraint. And that's what you're progressively making changes to some structure over time in order to maximize the amount of resources you have. Is there any instance in humans existing in some environment where they are not looking to gain as many resources as possible? I almost feel like I've not really answered the question. Maybe I'm just answering something related but distinct. I almost feel like adaptation, change to some structure, is done in response to some change, right? The ability to adapt just means to change, and you are doing that in response to the environment itself, which changes. The environment changes, therefore we change. To what parts of its environment is the organism adapting? The organism is adapting to those parts of its environment that change. Yeah, I still feel like this is stated. It's not really getting at the concrete stuff. I like this. This is fun. I'll bump it up to 5 and continue. All right. I think that's it for me today. It was actually a really good session, actually. In particular, the Fosbury flop discovery was pretty cool. That was a real I don't know, that was a real discovery. That was really cool because I've been wondering that for a long time, like how the meta changes and where the drive to change the meta comes from, and how does it end up changing. And yeah, so that was a really good discovery, and yeah, exploring the adaptation thing, that was cool as well. So yeah, that's going to be it for today. Um, I hope you enjoyed this session. I hope it wasn't boring, but if it was, let me know. Like, I want to hear if it was boring. Like, I have ideas for. I think I mentioned this in the introduction, but whatever. I'll say it again. Um, I have a bunch of ideas for content related to supermemo and quantified learning and learning with spaced repetition systems in general, incremental reading, incremental learning, all of that stuff. So, like, I want to make videos on actually like programming projects. Like, I can't. It's difficult to show with the virtual machine, but hang on. If I was like just over here doing my programming, and maybe I'm focusing on the programming, and then importing items, showing you how I import items from my programming projects into supermemo actually while I'm working on a project, and sort of the tools that I've been developing as well. Like, I've got a whole bunch of plugins and stuff that I haven't released yet because they're all in kind of a broken state at the moment, but they will gradually be approaching completion. So there's a huge, endless depths of stuff to talk about with supermemo, and whatever you're interested in, just let me know in the comments or on Twitter. You can follow me at Experilearning. So that's EXPI RI. Oh, I'll put it in the description. Anyway, like I just said, I hope you enjoyed this, and I'll see you in the next video.